Let us continue with the study of a code tree in convolutional codes. Let's see here how to generate a code tree for the encoder such that for any message input given to us, the code tree should give us the coded output. Always remember that the code tree starts at node A. If the input message weight is 1, then the path of the tree goes downward towards node B and the output is 1, 1. Otherwise, if the input is m equal to 0 at node A, then path of the tree goes upward towards node A and the output is 0, 0. Similarly, depending upon the input message bit, the path of the tree goes upward or downward. The nodes are marked with their states A, B, C or D. On the path between two nodes, the outputs are shown. Let us see how to draw a code tree. The initial state of the encoder is at 0, 0, that is state A. So at the start, the node is marked as state A. Here, we have two branches, upper branch and lower branch. We know that whenever we have m is equal to 0, that is input bit equal to 0, we go in an upward direction, and whenever input bit is equal to 1, we travel in a downward direction. So if you assume m is equal to 0, with the initial state m1, m2 is equal to 0, then we will have a combination 0, 0, 0, and for these inputs we are getting v1, v2 is equal to 0, 0. By shifting these input bits one bit towards right, we are getting next state of the encoder equal to 0, 0, so that is equal to A. So we have encoder at the state A will transmit output 0, 0 and will go to the next state equal to A. On the other hand, if we have m is equal to 1, then we will have m is equal to 1, m1 and m2 we have 0, 0. So for 1, 0, 0 combination, we are getting v1, v2 is equal to 1, 1. If we shift this data 1, 0, 0 towards right by 1 bit, then we will have m1 is equal to 1 and m2 is equal to 0. So the next state is decided on m2, m1, that is equal to 0, 1. 0, 1 corresponds to state B. So you can see in the figure, encoder will transmit 1, 1 and will have a next state equal to B if m is equal to 1. Again, at node A, which is marked with green arrow, if we have an input equal to 0, our previous input is also equal to 0. So we can see for a 0, 0, assuming m2 is also equal to 0, we have 0, 0, 0 combination, and we know that v1, v2 is equal to 0, 0. The next state will be again equal to A. So A, from state A, the encoder goes to the next state equal to A by transmitting an output equal to 0, 0. If we consider the lower branch indicated at a green arrow, for m is equal to 1, considering the previous input equal to 0, we have m is equal to 1, m1 is equal to 0, and assuming m2 is equal to 0, we have 1, 0, 0 combination, and v1, v2 is equal to 1, 1. Next state is obtained by shifting the bits towards right. So we have m1 is equal to 1 and m2 is equal to 0. So we have 0, 1 combination which corresponds to state B. So the encoder goes from state A to the next state B with the output equal to 1, 1. If you check the other branch, that is indicated by a blue arrow, at node B, if m is equal to 0, then for the previous input equal to 1, we have m is equal to 0, m1 is equal to 1, m2 is also assumed to be 0. For 0, 1, 0, if you see the table, we have v1, v2 is equal to 1, 0. If we shift these bits towards right, then we will have m2 is equal to 1 and m1 is equal to 0. So for 1, 0 combination, the state is equal to C. So the encoder moves from state B to C with the output equal to 1, 0. If the input bit is equal to 1 and our previous bit is also equal to 1, that is m is equal to 1, m1 is equal to 1 and m2 is assumed to be 0. So for 1, 1, 0 combination, we are getting v1, v2 is equal to 0, 1. If we shift this data towards right by 1 bit, we have m2 is equal to 1, m1 is equal to 1. Now 1, 1 corresponds to state D. So the encoder will go from B to D state with the output equal to 0, 1. Here we can note that upper branch is equal to 0, 0 and its lower branch is equal to 1, 1. In a similar way, if you consider the second branch, upper branch is equal to 1, 0 and the lower branch is equal to 0, 1. So you can note that whatever is the bits of the upper branch, you are getting complement of those bits in the lower branch. Now, for the same example which we considered in our last video, for the message sequence 110, let's see what is the code word. Now from state A, the first bit is equal to 1. So we travel in a lower branch. So the encoder moves from A to B with the output equal to 1, 1. Then the next bit of the message sequence is equal to 1. So from state B, the encoder again travels in the lower branch and moves to state D with the output equal to 0, 1. The third bit of the message sequence is equal to 0. So from state D, encoder moves into the upper branch and goes to state C with the output equal to 0, 1. Therefore, the coded word for the given sequence will be 1, 1, 0, 1, 0, 1. Like this, you can find the code word for any given message sequence by using this code tree. If one carefully observes the code tree, one will find that the branch pattern begins to repeat after third bit. This is shown in the figure. The repetition starts after third bit since message bit is stored in the shift registers of the encoder for 3 shifts. If the length of the shift register is increased by 1 bit, then the pattern of code tree will repeat after 4th message bit.